Hi, I'm Joel. I founded a company called Bigleaf Networks, but today I'm going to talk about low Earth orbit satellite like Starlink and how you can use that for business connectivity needs. I'm here at my home office, and notably I don't have any landline connectivity. I have a fixed wireless circuit from a local regional wireless ISP or WISP, a cellular option, LTE connection, as well as a geosynchronous satellite option. And so we'll add to those a ViaSat through Starlink and take a look at what it does. To install Starlink, you first use their app to scan the sky to see if the location that you're planning has a clear view of where their satellites will be flying by. Welcome to my networking rack here in the house. In here I've got a switch and my Bigleaf router, my SD-WAN router, and there's 3 WAN circuits connected. We're going to hook up the 4th today. We can see here I'm logged into the Bigleaf web dashboard. I pulled up my house, and on the overview page I can see I have 3 WAN circuits configured so far. What I'll do is I'll go into our configuration tab here, go into edit mode, and I'll add a new WAN circuit. You can specify geostationary or low Earth orbit for your satellite type, and the platform will adapt accordingly. And just a moment ago, the tunnels came up. We now have some graph data. I want to address a few questions I think might be running through folks' minds. First, how do I think about Starlink versus most landline type circuits, fiber, cable, DSL, that kind of thing? And I think the health alarm data we can see is really useful to know how these comparisons sit. If I was to go pull up another customer site, which I'll do here. So this location, we have some Comcast fiber. This is in Oregon. This is a typical fiber health graph. Literally nothing. This circuit above here, this is a cable circuit. Looks pretty clean as well. I mean, this is, users are not going to notice too much of what's going on here. You've got a little bit of jitter, upload and download at times. I would say this is pretty squeaky clean for a cable circuit. You can see them totally clean sometimes, but this is a nice cable circuit. We see them with plenty of packet loss and other issues at times. We'll take a look at another location here. This top circuit here is, again, Comcast fiber. So we can see, looks pretty clean. There's a couple blips, so this one could be user impacting. This is middle of the day. You have basically a mini outage. And then Frontier Fios, we'll take a look at that one. Again, looks pretty clean. A couple blips there, not too big of a deal. So back to my house. If you compare those graphs against the Starlink graph for a same time period, I mean, it's got periods, middle of the night, where it looks pretty clean, but during the day, there's definitely a lot of variability. And that's what I would probably highlight. With most wireless type connections, they're going to be more variable than a landline circuit, yet they are also a great redundancy path. Throughput-wise, that can vary as well. So, fiber is typically going to offer you more throughput than what we're seeing with Starlink, which is around somewhere between 60 and 120 meg down, and upload is very variable, up from 0 to 15 megabit up at my location here. So if I take a look at the health of the other paths, let's take a look at ViaSat. So ViaSat is a geosynchronous satellite, and we can see that quality-wise it's actually very good. Now this graph doesn't reflect the absolute latency of the path to traverse to geosynchronous orbit and back. The latency that our platform measures is in the form of relative one-way latency. So our technology does some things to adapt for that, knowing that geosynchronous satellite does have that higher latency just kind of in the background. You might wonder, well, what's the difference between geosynchronous satellite and low Earth orbit satellite? And I drew a cute little diagram here to show that. So if you've got my house, the red depicts essentially what is happening with the low Earth orbit, where there's a shorter path from my house to the satellite to the ground station, which then is connected via fiber to whatever data I'm reaching, some data center. Whereas the geosynchronous satellite is a much larger distance, and this is not to scale. The difference would be more significant than what you see here. So the reason the latency is much lower is because it's taking a much shorter path just geographically. The time of flight of the RF signals is reduced. Now, if we compare against the LTE circuit I have, the LTE circuit is much more consistent in its behavior and much lower in packet loss, but the throughput's a lot less. And when I've tested here, I'm getting about 4 megs each way on that circuit max. And then lastly, the fixed wireless circuit I have from a local residential fixed wireless provider, we can see that during times of load, there is significant jitter and packet loss. I'd say it sits in between the LTE and the Starlink as far as variability. So all in all, each wireless circuit does have its pros and cons, and you need to look at what's available in your area and trade-offs of throughput and performance characteristics. Now, what about a static IP address? That's something that a lot of businesses need to be able to deploy with certain use cases, VPNs or hosting a server, that kind of thing. And none of the circuits that I have a standard static IP address. They're all using a DHCP provided NATed IP address. And the nice thing is with Bigleaf, I actually have a static IP block. Bigleaf creates a tunnel across each of these circuits and delivers a single public static IP address over them, just like you would get if you had BGP in a very carrier-grade enterprise environment. Lastly, do you need SD-WAN to make use of low Earth orbit like Starlink? Well, in looking at the health of the circuits at my home here, I would say yes. I mean, if I had just this one circuit, or even if I had multiple circuits with a less sophisticated load balancing QoS mechanism, I wouldn't be able to do things like voice calling or Zoom, those sorts of sensitive applications in a reliable manner. And we can see examples of that here. So I had some Zoom calls this morning. All this green, what's it saying, VoIP was the Zoom traffic. And we can see that the SD-WAN platform really had to adapt hard to make best use of that. So here's my LTE circuit. It used that for upload traffic. This was around what time? 10:30 to 10:50 a.m. And we could see that the alarms were fairly low at that time. Level 2 jitter was all that it was seeing. And the downlink went, looks like in part on the fixed wireless circuit in that, let's see, 10:40, 10:50 time frame. It's kind of jumpy because it was, I think, moving the traffic around. And it's likely because alarms varied. So there's some traffic that ended up on the fixed wireless, and then other traffic ended up here on the Starlink circuit at that time. So the platform was adapting to make sure that each packet was writing over the best possible circuit. So if I didn't have that in place, my Zoom quality would not have been as good. Now, would it have been unusable? In this case, no. I mean, the Starlink alarms aren't terrible at that time. I mean, if they were level 4 or 5, yeah, at that point, that's when people are unclicking their video, they're going to just audio or saying, hey, can I call you on the phone? Another SD-WAN feature of note that Starlink really will need to be successful in the business environment is something that can provide QoS over very variable bandwidth circuits. Here's some iPerf testing through the platform. We can see this is download testing. I mean, this is just raw iPerf traffic varying between 50 megabits a second up to 100. In the upload direction, we see traffic varies even more considerably, 9 megs down to 1 meg. If you just have like a static QoS policy applied to the circuit, saying it's 10 megs or something, that QoS isn't going to work. The traffic's going to hit constrictions within the Starlink service, get buffered and either dropped or delayed. So you need a platform like Bigleaf that can detect that variability in bandwidth, adapt to that, and ensure QoS prioritization through that path even as conditions change. So in conclusion, I think Starlink and low Earth orbit are fantastic technologies. I'm really excited about what they bring to bear for folks in rural areas like me and businesses that can't get good landline connectivity or need a really solid redundant path that offers more throughput than LTE can. I think I would combine it though with SD-WAN and another circuit if you have any business critical use cases, and we'd be happy to help you out with that at Bigleaf. But thank you for watching and look forward to sharing more with you again.